All right, number 2 on the More worksheet, the half-white sheet, and it says, I have a 6 ohm resistor and an 18 ohm resistor that are connected in series to each other, and then that combination is connected in parallel to another resistor and a battery. There's a voltmeter reading 12 volts across the battery and an ammeter in the third resistor that's 1.5. Draw a schematic and find all unknowns. So I have a 6 and an 8 that are in series with each other. That's connected to a third resistor and a battery in parallel. There's a voltmeter, so I actually have to draw a voltmeter, reading 12 volts across the battery. Notice that's a parallel connection. The voltmeter, it's the scary vampire. It is attacking. You don't have to unhook anything. It just literally goes right over what it's measuring. And then an ammeter in the third one, and notice I have to erase a section to insert my ammeter. Just like when you do the lab, you actually have to break the circuit somehow. There we go. All right, this is asking about the tile, all different voltage, current, resistance. It wants the whole tile. So this section is in series by itself, so that's going to be my first section. I'm going to just call them 1, 2, and 3. So 1 and 2, and then the total of just the 1 and 2 clump, and 1 and 2 are in series with each other. So I have 1, 2, and 3. Then this column is going to be the first column in our big, gigantic circuit, the big parallel circuit. So this is just my 1 and 2 combo. That's with the third one. And then my total for everything. This is your battery info. And this combo, the third, and the battery are all in parallel with each other. And anything that goes in this column will automatically go in this column and vice versa. This down here is your this is the main circuit. And then up here, this is just the little parallel, the little series portion. So I'm going to go ahead and finish out my charts. VIR, just like Ohm's law. S starts me off with S plus, S plus. VIR. And P starts off with psst. And don't forget, whatever symbol you're using to remind you that the equation for parallel is that inverse one. All right, let's fill in what we know. I have 6 and 8 are my resistances up here in the series part. I don't know the third resistor. This ammeter is only telling me the current that's coming through the third resistor. So there's a total that comes out of the battery. 1.5 will opt to go this way, and then there's going to be some more that come around this way and come back. Current is like counting. That's like the turnstile. Current is like counting. So that 12 over the battery, that's the battery for the main circuit, that goes here. And the 1.5 amps is only through the third branch here, and so that's there. I've got all my knowns down, so all I have to do is solve. This plus means I can add regular, so 6 plus 8 gives me 14. Hold on. It's an 18 ohm resistor in the problem. I apologize. It says a 6 ohm and an 18 ohm resistor. All right, so 6 plus 18 then will give us 24. Remember, anything in here also can go here, and vice versa. It's like this entire thing has been inserted here. I've got a same, so I can do 12 all the way across. Again, 12 can go here. Divide down, and it's just like it is on the paper. DD, divide down. It's 12 over 24. Don't try and say 2. It gives me 0.5 as my current. So 0.5 all the way across because it is an S. Multiply up, I get 3 and 9, 18 times 0.5. And I want to check and make sure that 3 plus 9 does equal 12, and I'm good to go. Anything here is also here. This plus means I add them up, so 0.5 and the 1.5 gives me a total current of 2. Divide down, 12 divided by 2 will give me 6, and 12 divided by 1.5 will give me 8. This is the parallel. Notice it's smaller than either of those, and it's greater than 1. That means that coming out of the battery I have a current of 2, and 1.5 go this way and the other 0.5 go here. And remember, the difference in this bar and this bar is everything here is 12, everything here is 0. So the voltage drop across this is 12, the voltage drop across the entire series is 12. And inside of there it's going to split up over the first resistor, so it starts at voltage of 12 and it drops down by 3, and then it drops down by 9 and ends up back at 0. So my 3 and my 9, the voltage drop.